The purpose of this video is to begin working with SAS. And so we're going to start out by learning a few very useful procedures in SAS. So here we are in SAS, and the first thing we want to do is we want to bring our data into the SAS program so that we can work with it. And we're going to use the same method starting out here that we used in the previous video, which is to use the lib name statement to create a marker for a particular folder on our computer's hard drive where the data are going to be located. So if you remember, we start out, we write lib name, and then we have to give some name to the marker. And I'm just going to use the one we used last time. I'm going to call it data. And what I want to do is I want to find the folder where my data exists. And so what I'm going to do is I'm going to go over here to Windows Explorer, and I've created this in-Hanes folder, and inside the data folder, this is where all of my SAS formatted data sets are. And so I'm just going to copy the address as text again, and I'm going to put that here in the lib name statement line of code. And you remember we have two single quotes and a semicolon. I usually write those first, and then I just use a Control V to paste in that name. And so now we have this line of code that will create a marker called data that points to this particular folder. And I'm going to go ahead and save this. And where do I want to put this? I think I'm going to put a new folder, which I'm going to call this analysis. I like to keep my data and my analysis SAS code in separate folders. So I'm going to put this here, and I'm going to call this preliminary analysis version 1. And I tend to put a version number here because as you're working through your analysis, you're going to be editing and creating new SAS code. And sometimes you start out heading off in a different direction than you were heading previously. And so you're changing the code a lot. And usually when that happens, I just go to a new version number. And so that I have an archive of what I did previously. I don't write over it or change it or break it. So I'm just going to start here with version 1. Now the next thing we want to do is we want to bring our data into our SAS program. And let's just start out with one data set. Let's just take the top one here, demo_e. And I'm just going to start out by introducing the structure of the code that we use, and then I will explain it a little more completely. So when we are bringing a data set into SAS to work with it, we use a structure of code in which we first write the term data, and then that is followed by some marker similar to the markers that we used in the lib name statements. We'll talk about that more in a moment. And that's followed by a semicolon, and then that is followed by the command set. And then there is another marker followed by a semicolon, and then we finish it with the term run with a semicolon. Now, to understand what's happening here, we need to think about how the memory works inside your computer. So let's just draw a diagram here. Let's draw a picture of a computer. And you might or might not know that your computer has both permanent memory and temporary memory. Now, the permanent memory are the things on your hard drive. Those are the things that don't get erased when you turn your computer off. But your computer also has some temporary memory, sometimes called random access memory. And this, whatever's in memory, it gets erased when you turn off your computer. So what SAS is going to do is it's going to be reading the data into the program from the permanent memory where we have stored it. And it's going to make a copy of that data in the temporary memory. And when it's working with your data, it's actually working in the temporary memory. So it's making changes to the data, it's maybe rearranging the data, but it's not actually doing that to the data that are on the hard drive. You don't want to change the data in the permanent memory because you want to have an archive of that there. So what's happening in this data and set statement is that the set statement points to the location of the data in the permanent memory. And so let's go ahead and fix that one in our program here. And if we go back to the C drive, we can see the data sets that we have. Let's just start with this first one, demo_e. And if you remember in our SAS program, we already created a marker using the libename statement. We called it data. And this points to the data folder. So in our set statement, we can tell SAS that we want demo_e from the C in Haynes data folder. And so what we do is we first write the marker to the folder. So we write data, and then that's followed by a period. And then we write the name of the data set that is contained inside that folder that we want to take and put into the random access memory. So in this case, it is demo_e. And here we don't need to put any kind of file extension. This is already a SAS data set. SAS knows how to handle it. It will recognize the format automatically, so we don't have to tell SAS which kind of format it is. So now all we have to do to finish off this data and set combination statement is to choose a name for the data set that's going to be in the temporary memory. And this is just a marker that points to that data set so that you can communicate with SAS that you want to do something with the data set that it has copied and put into the random access memory. And so we can choose anything we want. We can use any label we want, and we put it here after the data statement. Now, since the original data are called demo_e, I'm just going to use the same name for the marker for the data that are in the random access memory. So I'm just going to put demo_e here. And so now we have a complete set of code that will read the data from the permanent memory and make a copy in the temporary memory and call that data in the temporary memory by the marker demo_e. So let's come over here and let's give this a try. So I will type data demo_e. That's my marker for the working memory data set. And then I say set. Now I need to tell it where the data are located, which folder. I've created this libename statement, so I'm going to type data here. And note that I'm sometimes using uppercase and sometimes lowercase. Actually, in SAS, it doesn't matter which you use. They're the same. And then now I need to tell it the name of the data set in this folder, and the name of the data set, the SAS data set, is demo_e. Again, I don't need any extension here because it's a SAS data set. SAS will know how to handle it by itself. And then on this side, I type run. And notice that I have a semicolon after the data, the marker, the set, the marker for the hard drive, and the file name. There's a semicolon, and after the run. So let's just go ahead and run all of these. I don't think I've run this part up here yet. So let's just hit the submit button up here and see what happens. Okay, so now if we look at the log file, what we can see is that it first set the libename statement. It says it was successfully assigned, so that's fine. And then when we did this data step, we can see that the first thing it did was it read in 10,149 observations from the data set data.demoe. And remember, this is our marker for the lib name statement. And then it took that and it said the data set work.demoe has the same number of observations. And so what it's done is it read the data from the original SAS file and it's put it into the working memory of the computer. So it indicates that temporary memory by this prefix work dot. And now what we can see is we can see that it tells us how many variables are inside the data set. So there are 43 variables inside this demoe data set that we now have in the working memory of the computer, and we can point to it by using the label that we defined here in the data step demo_e. Okay, now let's save this. I see the asterisk up here reminding me to save my file. Now, this structure is the basic structure of a chunk of code in SAS. And so what we will be doing is we will be often using this data and set combination to say what we want to work with, and then we will be putting code in here, and it's all ended with a run command. And so basically this is one chunk of code, and SAS will read in the commands that we're giving it, and then when it sees a run statement, it will go and it will run that chunk of code. Now, what we can do, now we have the data in the working memory. What I want to do is I want to show you how to start a new chunk of code with a data and set without calling the data from the hard drive again. So what we do for this is we simply repeat the name of our marker that we defined here. So demoe now points to the data set that's in the temporary memory. And if you put data demoe set demoe, what will happen, you can think of it as the computer is going to the temporary memory and picking up the data set that's in the temporary memory and is putting it back into the temporary memory. I don't know if it actually does that or not, but that's what you can think about it. This is the way, though, that you point to the data that are already in the temporary memory. And so we're going to start building some code here. And the first thing that I want to teach you how to do is how to see the names and the structures of the variables that are contained in the data set. And we're going to be using a procedure. And procedures always, when you call a procedure, they always start out with the term PROC that means procedure. And then that's followed by the name of the procedure that you want to use. And we're going to be using a procedure that's called contents. And usually when we talk about procedures in SAS, because the command is written PROC, we call that proc. So we're going to be using proc contents. I'll usually refer to the procedures in that way. So we want to use proc contents. And all we have to do is call this procedure and we will get the information about the variables that are in this data set. Now, I've already run this code up here. I don't want to run it again. I don't need to assign the library name that's already there. I don't need to read the data into the working memory. That's already been done. So I'm going to use a technique we learned previously where we highlight only the code that we want to use, and I'm going to save this. I tend to save right before I run things just in case things crash. I'm going to right-click and say Submit Selection, and let's see what happens. So you can see up here it says the proc contents is running, and now we are getting the outputs. So let's first look at the log file and see what happened. So here's our data set statement. It's reading in it's basically just pointing to the data. You can think of it as reading the data from the working memory and putting it back in the working memory. Then proc contents, so it's writing an HTML file I mentioned before that we are going to get outputs both in the output tab down here and also in the HTML tab. And then it ran. So let's see what we got here. So here's what it looks like in the output file on the output tab. And so what you can see is these are all of the different variable names that are in the data set. And there are 42 of them. And it tells you what kind of variable it is, if it's coded as a number, the length, and then it has a label that tells you a little bit about what the variable represents. Now, if we come over here to the HTML file, we get the same information, except that it's in HTML. So the formatting looks a little bit nicer over here. Now remember, the reason I'm using the output file as well is because we have the ability to right-click on the output file. We go to the edit and we can say clear all, and that goes away. So that's useful when we want to, when we're doing a lot of analyses and we don't want to sort of have long lists of outputs. So here on the HTML file, let's see what we have. So what do we see here? So this is demo E. It's in the working memory of the computer. It has 10,149 observations. There are 43 variables. And again, here's the same information we had before. Each of the variable names, the type of variable it is, and the length of the information that's coded, and then there's a label that indicates what the variable is. Okay, so now you can see the variable names and a little bit of information about each variable. But we often want to look more closely at the variables and perhaps specific variables. For example, we often want to know what are the distributions of the values that different people in our data set take for particular variables. So let's learn how to do that. So the first thing I'm going to teach you is how to look at the distributions of both categorical variables and continuous variables. And so what we need to do is we need to take a look at our data. And I'm using this demo_E, which is from the 2007 and 8. So let's just go to the .doc file again. And so when you're looking at the distributions of variables, you need to remember to think about if the variable is categorical or continuous. So let's look at gender. Here's an example of a categorical variable. It's numeric. The codes are numbers, but it's categorical in that the numbers represent different categories. So 1 here represents male and 2 represents female. Now that's different than a variable, for example, like RAD age in, which is the age in months at screening. This one, the value description is described as a range of values. And so the range of values goes from 0 to 959. So this is different. These are actually the numbers represent a number. They represent the number of months of the age at the time of the screening. So let's start with a categorical variable and think about how do we look at the distribution of a categorical variable. So let's use this one, RI age in DR. Okay, so what I'm going to do is I'm just going to copy and paste this because we're going to use the same structure, but we're going to use a different procedure. Instead of using proc contents, we're going to use a procedure called frequency. And frequency is abbreviated FREQ. Now, if we ran this code right here, it would give us the frequencies of all of the variables in the data set. We don't want to do that. It would treat even those variables that are continuous, it would treat them as if they are categorical, which means that for this one we saw before, which was the age at screening, where is it? Age in months at screening, right here. It would treat every different number that it found as a different category. So we might have, 6, 7, 8,000 different numbers in here. And so what it's going to do is it's going to treat those as categories. We don't want to do that. That's going to be a big mess. So what we want to do is let's just look at one variable, the gender variable. And so what we do with proc frequency is we say proc frequency semicolon, and then the next command is tables. And this is where you tell proc frequency what variable you want to see the distribution of. And the variable I'm going to look at is RIA gender with no E. Let me do that. RIA gender. Just like that. And this is enough. So we've called the data set that we want using the data set, using the marker for the temporary memory in both spots. Then we say proc frequency, FREQ with a semicolon, the word tables, and then the variable that we want to see, follow it with a semicolon, and then run with a semicolon. So let's run this and see what we get. Oh, I don't want to submit the whole thing. I want to submit the selection. Okay, so here we have the variable, we have the two different codes that are there, and the frequencies they report in the data set are 5096 for the ones and 5053 for the twos. Is that what we saw over here? 5096 and 5053. So this information matches the information that we actually saw. Okay, let's look at the distribution of a continuous variable. So I'm going to copy and paste this. And we're going to be using a different procedure. The procedure we're going to use for a continuous variable is called proc means. So means here means like the mean value, the average. And so for a continuous variable, the distribution, one way we can look at it is to look at the average, the mean value and the standard deviation, those sorts of things. So here, instead of writing tables, what we write is VAR. That stands for variables. So these are the variables for which you want to have the means and other information. So let's do the age and months at screening. Here is the variable name. I think I'm just going to copy and paste it. And here I have all caps. Before I was using lowercase. It'll work either way. I'm just going to make it look nice, actually. And so we have VAR, the variable we want to see, and then we need a semicolon. Now notice that this run down here is not blue yet. So when I put the semicolon in up here, that turns blue. Maybe you can't see it on the video, but you probably saw it become bold. So one thing about this, nice thing about this editor is that the different components of the code you're writing turn colors. And when you make mistakes, you will see that reflected quite often in the colors of the different components of your code. So as you get more familiar with this, as you get more experience, this editor, it will help you to recognize when you make a mistake in your code. So okay, let's try this. So let's try this proc means, looking at the age and months, and I'll hit submit selection. And so here we have, I'm going to go to this output again. The number of individuals is 9,710. The mean value is 375.5, and the standard deviation is 287.6. The minimum value in the data set is 0, and the maximum value is 959. So I'm already thinking, like, what does this 0 mean? Does it tell us? Oh, it says it has a 0. Age and month, so it must be a newborn then, I guess. So here we have 9,710 who have data values and 439 who had missing data. So if we look at the number, the in that we got here, we got 9,710. So these are the individuals who have data. And if we look over here in the HTML version, we basically just get the exact same information. Now, this is one way to look at a continuous variable. There's another procedure that is useful for looking at a continuous variable. Let me teach you that one. And it's called Proc Univariate. U-N-I-V-A-R-I-A-T-E. Proc Univariate. And if I remember correctly, we also use variable. It turned blue, so that's probably right. So let's use this same continuous variable. So Proc Univariate is good for continuous variables. And I will show you what it gives. And again, it's Proc Univariate spelled out, semicolon, VAR, just like in means, and then you tell it what variable you want to look at. And you could put, I should say for all of these, you can put more than one variable in a single table statement or a single variable statement. So we could look at multiple variables at one time. Let's see what happens when we look at Proc Univariate. Submit selection. So here what we find is, so up here you get different information. You get the sample size, you get the mean and the standard deviation. There's some other metrics here that if you look up, you can find out what they mean. The one that we often want to look at, though, is the quantiles. And what it gives you is, it gives you, these are this is the 50th percentile is the median value. It gives you the third quartile. That's basically the 75th percentile, the 25th percentile. And it gives you all of these different percentiles of values. So you can sort of see how the data in a continuous variable are distributed looking at this one. So this one is quite useful. Now, another thing that Proc Univariate can do, which is nice, is that it can give you a histogram. And the way you get a histogram is after the variable statement and the semicolon, you write the word histogram. And then you write the variables for which you would like to have a histogram. So let's run this and see what we get. And I should save my code. I haven't done it for a while. Let's run this and see what we get. So I'm going to right click, submit selection. It's running. So here in the HTML version, now we also get this histogram of the distributions of the different age at months of different individuals who are in our data set. So this is very nice. And if you want to have more bars here, there's a way that you can do that. It's after the histogram and the variable or variables that you want to see, you in between the variable name and the semicolon, you put a slash, and you use a command called, it's the number of midpoints. So in MIDPOINTS. So that's how it's abbreviated, in MIDPOINTS. Number of midpoints equals, and you can choose the number of bars, essentially, that you want to have in your histogram. So let's see what happens if we put 100 bars in here. Now you can see that we have much more fidelity on the age of months. So you can adjust the number of bars that you want to see there. So this should be enough to get you started with looking more closely at your data. These proc contents, proc frequency, proc means, and proc univariate. And the one last thing I want to do before we finish here is I just want to show you that how the structure of the data of the SAS code can be. So we could do all of these things in one single data set statement. For example, like this would be a valid one. In fact, we can just run it now. Let's see what happens. So you see it did all of those things. There's the proc contents, then it did the proc frequency, then where's the proc means? Did it not do the proc means? Oh, it didn't do the proc means because I forgot to put it in there. But the proc univariate is there. Okay. The point here, though, is that you can put multiple procedures inside this data set statement between the data set and the run. So what basically SAS will do is it starts here, it starts reading in everything, and then when you say run, it goes, that's when it starts doing all of these things. Okay, so what did we learn here? We learned how to read a data set into the working memory. We learned a few procedures to look at the data, and we learned a little bit about the structure of SAS code. Now, I should save my code here. Now, one thing is this demo E, if I close the SAS program, this is going to be lost from the memory. So later on, we will be learning how to write something permanently to the memory. But just so you know that if you close the program, whatever data are in the working memory will be lost.